Hello, welcome everyone. My name is Daniel Moyer. I'm a sales support trainer here at Briggs Stratton Energy Solutions. With me today is Mike Schaefer, one of the other trainers here. Welcome, Mike. What we have for you today is off-grid living with SimpliPHI Power. This is a NABCEP accredited course, so we are going to be issuing NABCEP continuing education credits. At the end of this talk, I will be providing my email so that you can go ahead and email us your full name. Be sure you spell it out for us so we get it correct on your certificate. And then we'll go ahead and issue those certificates as well. One really exciting thing that's coming up really quick is RE Plus. This is going to be in Anaheim next week. It's here already. So if you are going to be attending, please stop by our booth. There's our booth number there. If you need a ticket, I have a couple of free expo passes left. And if you need a ticket at the end of the talk, email us and I will be sure we get you a link to get you a free expo pass. It's not the full conference pass, but the expo pass. If you're going to be there, please stop by our booth. I will be sure you get a ticket to the celebration from Solagent, and we're also a co-host of that as well. We're going to have a nice booth there with a lot of the products you're going to see today in the presentation. Please stop by, join us. If you need a ticket, wait for the email. I'll get you a ticket. And if you are going to be there, stop by the booth, and I'll be sure you get a wristband to go to Celebration. That, I believe, is on Wednesday night. So stop by and take a look. Today, what we're going to be talking about is really the history of off-grid, the types of off-grid systems. We're going to talk a little bit about sizing. I think that's really important for off-grid to understand. You know, if you don't size it correctly, they're going to lose their power because they don't have grid as a backup. Lead-acid battery replacement. That's been something that's been very popular with some of our products. Some calculators. We're going to quickly go over the products at the end, and then we'll talk about one of our installer programs. So I think this is a great slide. I went back and looked at some of my old home power magazines, and if anybody has been in this industry a long time, they probably remember this publication. It's out of print, but I wanted to go back and kind of look at what the history looked like, and I came out with this ad that I found in the back of a home power. And look at that. A Siemens 100-watt solar panel was $477. That's $4.70 a watt. And now, you know, I've seen them sub 50 cents a watt. So we're really come a long way. And when we were sizing these off-grid systems back in the day, we really had to be very careful about the loads we put on the systems. And really, the whole industry as we know it, it started in the off-grid industry. I currently live up in Arcata, California, which is up in Humboldt, California. And we had a lot of off-gridders. I'm thinking of John Schaefer at Real Goods, Dave Katz at AEE Solar, and Backwoods Solar, and a lot of these Northern Arizona Wind and Sun. These were the companies that really started this industry, and then now it's developed into this huge on-grid market. But there is still opportunities for off-grid work, and this training, I hope, will set you up successfully for, or even better than successfully, to start to help. I love the picture of those old solar panels on the right over there in that old Trace inverter that you see up at the top right there. So prices have really come down. One thing I realized is the history of Briggs & Stratton. Briggs & Stratton is over a century old, and we kind of got our start in some of the off-grid markets. One of the examples here, this is one of our gasoline-powered washing machines. And these were distributed way back in the 30s, and we actually continue to produce them up until the early 80s as well. So we have a long history. Briggs & Stratton is going to be a company that's there to support you. We're going to be around to support your warranties going forward. We also have a great name brand recognition when you're talking to the homeowners and presenting our products. So if you ever are out in Milwaukee, this is actually in our museum at our headquarters, and we could definitely give you a tour and show you this thing in person if you like, amongst other things that Briggs & Stratton has made. Going back to home power, really, you know, I found this great article, Randy Udall, and he had written this article. And one of the things you realize is living off grid, the dirty little secret of living off grid was propane, right? We had propane water heaters, propane heaters, propane refrigerators. So Up here in Arcata, I worked for a long time at a company called Sunfrost, and Sunfrost made DC compressor refrigerators. So it was an idea that we could wean ourselves off of that propane, which is the dirty little secret. So it really was an interesting article written by Randy Udall. So if anybody still has a collection of home power, please put it in the Q&A. I should have mentioned that earlier. If you have any questions or comments during this talk, please put it in the Q&A. It's at either the top or the bottom. Mike here will be monitoring those Q&A as we go along. I can answer them during the presentation, or we can address them at the end. Randy Udall is very active in the industry, and I would credit him for a lot of the developments that we know today. So again, another thing is talking about NABCEP, and I found this article in this NABCEP, this article of Home Power, a NABCEP ad, and they've also been very instrumental in this industry in developing educational resources. So kind of a flashback. This is, I promise you, the last home power screenshots I'll show you. But what I kind of wanted to mention is we've seen net metering changes here in California, where you can no longer use the grid as your battery, if you will, where you can't no longer send your kilowatt hours back to the grid during summer, during the day, and then use those credits up as your battery during the winter and during the night. So what I'm seeing in the industry is these off-grid principles that we're about to talk about really are starting to apply to grid-tied systems in net metering, right? We're going to install solar, we're going to install batteries, inverters, charge controllers on grid-tied homes, and they're going to do everything in their power, excuse the pun, to not use the grid, whether import or export to the grid at all. And so what we're kind of seeing here is that, you know, if you're this blue is self-consumption, this green is exporting to the grid, and this red here is you using the grid. So if you're no longer getting anything for the green because you're no longer on a net metering plan, you need to store that in a battery and then discharge that energy during the nighttime. And there's if anybody is from around the country, you will know that a lot of other states, municipalities, utilities don't offer a net metering agreements. And if they do, those may be jeopardized coming up because people are looking at what's happened in California. I have an entire other talk that we talk almost the entire hour about net metering. But I went back and looked at a couple of old home power magazines where what were we thinking about net metering and the changes that were coming along. So interesting articles there. This one here is from 95, which is when NEM 1.0 went into play. This one you see on the right here, which is when net metering 2.0 took effect, which was in 2017. Course, understanding, and we're going to talk about this, that during certain times of the year, right, you get less sun, so we need to be able to size our systems, right? And we're going to talk a little bit about why a generator is going to be very useful in an off-grid system. So this is a picture of a house actually up here in Humboldt County. It's an off-grid home way up here in the Redwoods. And if you look at this home, you think about what it might cost to get to the utilities to that land. So you've bought a cabin and you might get a quote for $30,000 to trench and bring in utility to the property. It might be $30,000 to install an off-grid solar system. So look carefully at what the cost benefits are, right? If they need to add another transformer along the pole, maybe there's a zoning or easements that come into play when you're having to bring grid power out to the property. So as you're thinking about these, there's a lot of cost factors associated with them. And, you know, $30,000 might seem like a lot for an off-grid system, but when you start to look at what it might cost to get the utility to a land, they can also add up. A lot of times back in the off-grid days, we would have a generator. We wouldn't have solar. We wouldn't have batteries. You would run the generator. You probably start it up in the morning, run the generator during the day. And then when it was time for everybody to go to sleep, you'd shut the generator off. But now what we're seeing is with these lower cost photovoltaics and more importantly, lower cost energy storage, we really can start to implement PVs. PV photovoltaic energy storage. a lot of times when we did have these off-grid systems back in the day, we would have both a generator and energy storage systems combined. Why? Because if I were to size a photovoltaic system to get you through the dead of winter, that solar array would be way oversized for summer. So you'd end up buying all this extra solar. And what we would do now is a lot of times when there's a big winter storm, when the nights are long, what we can do is use a generator to use a two-wire signal to start up a generator, and then charge up that battery and then shut the generator off. When I was out at Midwest Renewable Energy Fair, if anybody actually had made it to the Midwest Renewable Energy Fair this year, please put it into the Q&A. I'd love to hear what you thought about it. But there was a lot of talk about wind and micro hydro, and this used to be a big part of us. The good old Pelton wheel. Micro hydro, right, has a time and a place in topography that has a lot of elevation change, that has a lot of water, that a lot of flow that allows it to work. But wind also I think it's still, and if you are somebody that's doing micro hydro, do wind, please put it in the Q&A because I'd love to hear about it. I will say this, that the solar line of inverters, which we pair very well with, does have the ability to bring in wind. Micro hydro usually still requires some other controllers, load dumps and stuff like that. But NABCEP absolutely still offers a certificate for small wind installers. So if somebody has that, I'd love to hear about these and let you know if you're still doing that as well. We do offer 24-volt batteries. We're one of the few people in the industry that's still offering lithium-ion batteries in 24 volts. In fact, we even have a 12-volt option as well. So let's talk a little bit about the types of off-grid systems. One of the most basic ones are kind of these all-in-one packages, and these indeed are an off-grid system. What you're seeing up on the top right is actually a product we make. It's called our Big Jenny. We have another version called the Little Jenny, and it has everything you need, right? It's got the photovoltaic panels, it's got a charge controller, it's got an inverter, and it's got one of our lithium-ion batteries in it, and it's able to provide what you need, right? This is going to be more of a small cabin or camping. I would think of it as that way. There's also other small, like a solar lantern, right? If you think about a solar lantern, that's an off-grid system. It's a small one, but what it has all the parts and pieces that you would expect to see: energy storage, charge controller, the batteries, and a load built in there. I've also seen radios as well. This is a small radio from a company called Sea Crane, which is actually up here in Humboldt County as well. Let's step it up a little bit. Let's get a little bit more fancy. Another type of off-grid system is no storage. What I've seen these historically used is to pump water. So we have or use a fan as well. So we have a photovoltaic system. We have a water pump. Usually you need a pump controller, a linear current booster. What that can do is take that energy from the photovoltaic panels, pump water uphill, pump it up to a tank that you have sitting up above the cabin, and then you essentially use that water as the elevation as the battery, right? Every foot of elevation is you could think of it as voltage, and have that voltage ready. So when you need to use water at night, you can then simply turn on a faucet, turn on the valve down there at the house, and allow that water to come on, flow down. Usually there's a switch, a float switch that will then turn off the pump when the tank is full. So again, there's no storage, and these are systems that you would historically see back in the day as well. Let's step it up a little bit more. Let's go to a DC only architecture. Now we're gonna get fancier. Don't worry. We're gonna bump it up to what the modern days is, but I would see these when we would sell our Sunfrost refrigerators that were DC. I would see homes that ran on DC loads only, right? We have, and by not having an inverter, we're able to be more efficient because every time we invert power, we're gonna lose something. Additionally, back when inverters were really expensive, you could save money on the system as well. But what we have is solar going into this Morningstar. I really like this Morningstar controller here. This is an MPPT controller, so I'm sure a lot of you understand that. It's a little fancier than their PWM controller here. We're taking solar in. This charge controller will then charge up the batteries. And once the batteries are full, it will go into a float so that the batteries don't get overcharged. We got a little DC breaker there. You don't necessarily need that because our batteries actually have built-in breakers into them. What I have is a DC light bulb, 24-volt LED bulb going into, I think that's a Blue Sea Systems power distribution block. And they're using the little, I think they're ATC automotive fuses. You can distribute off to lights, to other loads that are in a DC only architecture. If you notice, my refrigerator, though, is not going into that MPPT sun saver. It's actually flowing directly to the batteries. The reason is because that Morningstar actually also has a low voltage battery disconnect, and you can adjust that so that you don't discharge your batteries too low. The refrigerators, especially those Sunfrosts, I know for sure, had a low voltage battery disconnect built into the refrigerator itself. So I'm connecting that directly to the batteries. And if I would have connected that directly to my sun saver, I might have exceeded the 15 amps that's capable of being provided out of that load port on that sun saver. So DC architecture is another interesting thing I see is DC architecture maybe coming back into play in our homes again, utilizing Ethernet cables. Or if you think about a USB-C cord, those can actually, I believe, handle up to almost 100 watts. So imagine we have homes now with, instead of, maybe we still have the AC outlets, but now there's USB plugs on there where you could plug in DC loads. And NREL has a really interesting article on this. Everybody on this call is going to get not only a recording of this slide deck, but also the slide deck slides themselves. So if you're interested, you can click on that link and take a look. Getting a little fancier here, what we have now is that same SunSaver Morningstar charge controller, but what we've now added is a small inverter. So we can have some small loads on the home that are AC. What you see in kind of combining the batteries is a Morningstar battery combiner. And the batteries you see down there are some of our 3.8 24-volt batteries. And those will all be wired in parallel inside that Morningstar controller there. Mike, any questions or any comments? Did anybody like our home power articles?
Absolutely, yeah. We had a suggestion from Alfredo, I believe, for connecting with the archive. So in the Q&A, you should see a public link to download past issues. As a novice, that's one thing I'm excited to jump into, so thank you. And Haas also had a suggestion for a book, the Aggie and Archie OTG Energy Guide for Off-Grid Living. So those are all links posted by participants. Appreciate that. And feel free to check those out. Daniel, you can look at them later and comment accordingly too.
Yeah, thank you. Yeah, that's what I should have mentioned is that all of those old home power issues are still available. One of my favorite parts, getting one every month, was the code corner. And I recognize, code changes every year, but there's still a lot of great useful stuff in there. Let's step it up. I think this is where we're going to be living in a modern off-grid home. This is an AC only architecture, right? We got our solar arrays, we got a disconnect flowing into a solar hybrid inverter. In this example, we have a solar 12K. We have it paired up with our new 6.6 stacking battery. We're going to have that down at RE+. We're even going to have modules that you can physically stack yourself and take apart. They're going to be shells because we don't want anyone to get hurt. But they are definitely a new generation of battery that we just released. Also, what I'm showing here is one of our Briggs Stratton Power Protect 13K generators. And the Solar, which kind of is evolved a lot, right? Back in the day, we would have our Morningstar charge controller, our Morningstar inverter, an automatic generator start, all these different parts and pieces. But now it's all in one. It's a Solar, right? Like Noah's Ark, right? It's a hybrid inverter. And there's a lot of other companies coming out onto the market with hybrid inverters that put all the parts and pieces into one. And what that hybrid inverter, like I just alluded to, has a 2-wire signal to start. It's monitoring the state of charge of the battery, and it can start up that generator at a given point, usually around 20% state of charge that battery up, usually not all the way. I'm not going to float the batteries on a generator, but I'm going to get through a bulk charge, get the batteries charged up, and then shut that generator off. rinse and repeat. So really, I see this kind of architecture going forward, not the different parts and pieces. Definitely a hybrid inverter, AC only coupled systems. This is those Jennies that I was talking about as well. These are a little different than I would say than those Goal Zeros or those Yetis, although Yeti might be a cooler. These are I would call more expeditionary kind of style, where they actually come in these really nice Pelican cases, and they're really kind of more of a robust kind of expeditionary kind of, let's take it out on a long road trip, or a long off-road road trip or something like that. Whereas some of those other products are more designed for residential use as well. So this is kind of a fun slide. And if you think about back in the off-grid days, right, we would usually have a wood stove would be incorporated in the property, and you would have to keep that wood going, right? Keep that stove going for space heat, but then you would also use it for cooking. And you can see an example here where you're using, they got some pots and pans on top of that wood stove there. I like the Bico washer, right? Pedal powered washer, LEDs. So really, with the advent of these hybrid inverters that are more powerful, and the lower cost in photovoltaics, and the lower cost in energy storage batteries, this stuff really goes out the doors, and really you're able to eliminate this off-grid living. Doesn't have to feel like off-grid living anymore with the advent of really reliable long cycles energy storage from Briggs and Stratton as well. That being said, when you do have a customer that, say, living on grid home that decides to go off grid, it does take a little bit of education, and make sure the homeowners understand what living off the grid can be. There is a limitation to all of this. Of course, you can provide a large photovoltaic array and a large generator, but for example, say the homeowner wakes up in the morning and the batteries are kind of low by noon or 1 o'clock. The batteries are full, the sun's shining. Tell the homeowner, let them know that they can go ahead and do the wash, cook, do all the things, because if on an off-grid system, once the batteries are full, there's nowhere for that photovoltaic energy to go, right? The charge controllers are just going to throttle back. So have them do that things. Once evening time comes along and the sun starts to set, have them start to curtail those loads, and then that way they can go through the night on the energy reserves they have in the batteries. So little things, educating the homeowner can go a long way, and make sure you don't get that call saying my system's dead because I over discharged it as well. Space heating, if you look at a load profile of a home, most of the home's energy really goes into heating the home. Yeah, the lights, yeah, the cooking, water heating as well is a big one, but heating your home and heating water is where a lot of the energy goes. So I've kind of seen a drop off in solar hot water, and when we all go to RE Plus next week, I don't really expect to see a lot of solar hot water heating systems. You know, they have a lot of heat dumps, a lot of pumps, a lot of plumbing throughout the house. With photovoltaics becoming so cheap, and with the advent of these heat pumps, not only heat pumps for your home, but also heat pump water heaters, we can now use that photovoltaic electricity to just heat water with use electricity. Simplifies the system. But if anybody out there is still doing solar hot water heating, please let me know in the Q&A, and let me know that industry is still alive and thriving. NABCEP absolutely still has some certificates on that. And I've also seen people move away from a wood or propane heating by using heat pumps. And a lot of these newer heat pumps have inverter compressors, so they're not slamming the inverter or a generator with a really big surge. They're able to ramp down and provide more of a constant, maybe a small fluctuation on the power consumption as well. They don't have to be just mini splits, which is kind of that thing hanging on your wall. I've also seen air handlers as well. So as far as the homeowner's concerned, there's no difference between the two as well. A lot of times in grid-tied systems in the city, you see rooftop systems. There can be AC coupled or DC coupled. right? If we're coming back out to a house, we can do that as well. But with off-grid, usually the homeowner has a lot more property, and a lot of times what we see are these ground mounts. And a ground mount is usually all in the same orientation, and it's usually DC coupled as well. So in this section, I just want to talk a little bit about what affects a photovoltaics array power production. So in this picture, you're seeing, I believe these are, yeah, they're sun power they're probably A series 425s with the built-in Enphase, probably IQ7 pluses on these photovoltaic arrays. And what you're seeing is the production curve of that array in March. And it's an 8,500 watt array, but we're not getting anywhere near that. In fact, I think we're probably getting closer to 5,500 watts. So what are some of those variables that affect the amount of power production you get out of an array? Well, of course, the solar irradiance, or the amount of sun you get. So in that March day, the irradiance, the sun probably wasn't hitting that solar array at a perpendicular perpendicular angle. So we were getting there. Potentially in that March day, the temperature was kind of cold, which actually increases the voltage of the array and allows you more production. In the summer, it's going to decrease it. Shading, of course, and that's where microinverters or DC optimizers come into place. Where you see that picture on the left where you can avoid one panel drawing down the production of the entire array. Maximum power point trackers, right? That's pretty common. I don't see very many PWM charge controllers on the market anymore. Equipment inefficiencies, right? Those microinverters, right? We're converting that to AC, and then we have to turn that AC back into DC to charge a battery, and then turn it back to AC to power the loads. Inverter clipping, right? That IQ7 Plus doesn't have a 425 volt output, so you're going to get some clipping. And I would always get homeowners that would be looking very carefully at their power production graph and notice, the kind of the peak being clipped off. And I'd have to inform them that, inverter clipping is appropriate to a certain extent, but with a DC coupled system, we can eke out a little bit more production as well. Line drops, right? We're getting voltage drops. We're turning that power into heat on the wires as well. So, Mike, I think what we're going to do is we're going to have a little competition right here. So one of the things I think is fundamental to understanding living off the grid is the seasons. And that's something maybe we don't think a lot about. But what you're seeing down there is the picture of the sun in the middle of the Earth's orbit. And what we have for everybody on the call today, we have a Lego kit. I'm going to give away a Lego kit. What I want everyone to do in the chat right now, put in the number. So we have these different positions of the Earth going around the sun. What is the position of the Earth today that closest represents the different numbers on the Earth right now, right? So we have the equinoxes and we have the solstices. I'll give you a hint. We're coming up on a solstice. So put in the chat, the Q&A, what number of position on the Earth we're at closest today. And whoever gets the right answer, we're going to do a random drawing at the end of the talk. And we're going to mail you one of these Lego kits that shows a little home with one of our generators in our energy storage system. So again, what number on the diagram you see below is closest to the Earth's orbit today?
Yeah, and just to clarify for Michael, Q&A is where you need to enter that. Feel free to just ask a question by entering the numbers. But yes, chat is disabled. And you can do that throughout the talk. So 1, 2, 3, or 4. And as Daniel suggested, I'll pick a random name if you get the correct answer, and we'll send that out. Now, just to clarify, not officially Lego, just a brick set that we designed. But as you can see, it highlights the SimpliPHI 6.6 batteries and Briggs Stratton Power Protect standby generator.
Yeah, thank you, Mike.
I see some answers coming in, Daniel. Thank you.
Yeah, and just keep in mind the Earth is rotating this way. We're going around the Earth this way. And so as we're coming in, right, think about what if the sun is hitting the northern hemisphere, what season would that be? And if the sun is hitting the southern hemisphere, what season would that be? And then think about what season we're going into and what number we'll be on. So you can, with that, you can resubmit your answer if you feel less confident on what you have, and we'll still honor that at the end. Let's keep going. One thing to keep in mind that affects the production of solar arrays is air mass. So if we actually were at the space station today and we had solar photovoltaic arrays, our solar panels would be getting 1,400 watts per meter squared. But on the Earth's surface, we're getting less than that. We usually get about 1,000 watts per meter squared, which means that if I put out a solar panel that's 1 square meter that has 100% efficiency, I would be getting about 1,000 watts. Most solar panels on the market today are anywhere from about 20 to 25% efficient. So if I have a 1 square meter solar panel, I'll be getting about 200 watts or something like that. It's also important to understand that as we go up further in latitudes, the amount of atmosphere that the sun's rays have to pass through is greater. So there's less kind of energy reading. So if you live at the equator, you're going to get more than, say, living up here at one of the higher latitudes as well. So you can see this. What they do is a lot of solar panels have standard test conditions, which assumes a certain air mass, a certain cell temperature, actually a certain ambient temperature. But that's not necessarily a good indicator of a production of a solar panel. There's other ratings, nominal operating cell temperature, where they're not saying 1,000 watts per meter squared. They're saying 800. They're still giving you the air mass, but they're able to also look at cell temperature, not ambient temperature, which gives you a better idea of what a solar panel might produce. We've all seen an IV curve. Again, maximum power point tracking allows us to capture the most of the energy coming from an array. I get this a lot from homeowners. They'll say, I want a tracker. I think that if I can track the sun, I'm going to get more power out of it. And it's true that having a solar module perpendicular to the sun rays is going to give you the most power production. But even if it's off just a slight amount, it doesn't make a big difference until there's some sort of tipping point. At a certain point, the production of the ray is going to rapidly drop off. Think about like a bucket. And you put a bucket out in the rain, and you're going to get a certain amount of rain falling in the bucket. But as we start to tilt the bucket to the side, you could tilt it a little. It's not going to matter much. But at some point, you're really going to affect the amount of water that can kind of fall into that bucket. So Nathan Heston, who's my supervisor, he was a physics professor at Cal Poly, and he could talk us through this math a little bit better than I'm going to attempt to do. But what I do see is tracking for a grid-tied system really isn't worth it, especially if it's a 2-axis tracker. Now, in an off-grid system, I could see a single-axis tracker where we kind of tilt the panels up a little bit more in winter and tilt the solar panels down or a little bit more flat, and have that where it's only a seasonal adjustment. There's no motors or actuators that might be break on you, and then there you go, you got to redo the whole system. But let me know if anybody has done this. This is ZomeWorks. ZomeWorks had an interesting tracker where they actually had they're no longer making these, but it was just kind of a flashback to my off-grid days. I think this is Northern California here, but they actually had a refrigerant in these cylinders, and as the sun heated up some of these cylinders, it would track to one side or the other. But really, just understanding that a seasonal axis, a seasonal adjustable tracking might be something that's that you would want to look at in an off-grid system, right? A lot of the large solar farms, they're going to do an east-west axis to track the sun throughout the day. I'm talking kind of a change the attitude on a south-facing array. This was so there. I appreciated whoever had mentioned a book. Now we all have these auroras and open solars and all these energy sage and all these online tools, but I really appreciated that comment, Mike. Somebody said, get a book out. And I found here in the and I got to look up the title. I already forgotten it, but kind of looking through the library here at Sunfrost, I found this book, the Solar Home Book, and this is from 1976. But there's still useful concepts in here, and what this is showing us, this I actually used at Custer, Wisconsin, which is the MREA, and I looked. I did my presentation at 3 p.m., and this kind of allows us to see at normal would be pointing the sun, the solar panel directly at the sun, and then they have these different um, angles relative to the horizon, and the latitude, the closest latitude to Custer, Wisconsin, would be 48. So I can know that in the summer, right, that actually if we tilt that panel a little bit steeper, or less steep, I should say, that you're going to capture more of the sun. What this is kind of trying to show us is that in a winter month, you can figure out what angle the solar panel should be pointed at to capture the most solar insolation throughout that day, that month. So again, having some of these old school tools still work and are still applicable in a lot of ways. So remember, in an off-grid system, just like a home that's on grid with a net metering system, power is only produced where it has a place to go. And so if you have full batteries and the sun's still up, you can't export it, turn on some of those loads. Just to recap, what affects the production of a power array, right? It's temperature, latitude, the angle, and the ability for that system to take in power. Really quickly, we're going to do through sizing, and then Mike, we'll open it up here to some questions before we go too further. This is a great product of ours, our access system. We put a Solarc up top, 6 batteries. What we're going to do is we're going to size the system really quickly. First, we got to know how much energy the home uses. We also have to know how much power the home might use at any given moment, so that we can size our battery bank and our inverter, right? The fuel tank and the engine. Then we're going to figure out how much photovoltaics, how big our solar array needs to be, get a charge controller, get an inverter, and then talk about some wiring. So this is kind of a home I looked at, right? This is, if I were to live off grid, I'm still going to have the dirty little secret of propane. I'm still going to do my space heating, my water heating, my cooking, and my generators all going to be propane. But what do I want? I want some TVs, some lights, some water pump, and a microwave, refrigerator. I kind of used the LED lights as a placeholder. I probably wouldn't have, I might have 10 lights, but not on all at once. So this is kind of a placeholder for cell phone charging or computer charging. So what we look at is we look at the amount of watts a load will use, and then the quantity, and then look at the runtime hours per day, right? If you have a refrigerator that says uses 100 watts, it's not going to use that all day long. It's going to cycle on and off. But what we also have to look at is that if that refrigerator comes on, what's the surge, or what's that inrush current before it kind of ramps down. So we can see the continuous watt draw is around 1,700 watts. The surge is around 2,300 watts. So this continuous is going to help us size the energy reserves, where the surge is going to help us size the size of inverter we need. So there's kind of a little math to figure out that surge down there. But really what we have is 4.6 kilowatt hours per day we're going to use. So if we have 4.6 kilowatt hours per day, and we know the inverter is only 90% efficient, we need to bump that up. Now we're going to need 5.1 kilowatt hours per day we're going to be using. I also want to understand that in off-grid, we need to have days of autonomy. We might have rain or a storm come through, but usually it's going to blow through after about 3 days. I've also seen people do 5 days of autonomy. 3 days is a good measure. So I take my 5.1, multiply it by 3. Now I'm at 15.3 kilowatt hours per day. I also want to account for my battery. I never want to discharge my battery all the way. Usually in our old lead acid battery days, we'd go to 50% depth of discharge. Nowadays, you can go to about 80% depth of discharge on these lithium batteries and really not affect the cycle life. In fact, on our new 6.6 battery, you can go down to 100% depth of discharge and still get thousands and thousands of cycles on these batteries. We're going to stick with 80%. That means I need a 19 kilowatt hour battery bank. It just so happens the math works out perfectly that if I have 5 of these 3.8 kilowatt hour batteries, that's 19 kilowatt hours. Additionally, I could do a 3 stack of my 6.6 batteries over here that you see. That comes in at 19.8 kilowatt hour batteries. So we figured out how many batteries we need. Next, we got to figure out how much solar photovoltaic system, the photovoltaic system we need. Now, I could use this map here. This map is showing me the amount of solar insolation I get averaged for the entire year. What would be a better map to use is the map behind me. The map behind me that you see is actually showing the solar insolation data for the worst month of the year, like a December or a January. Because if I use this map, I'm going to have an undersized array for winter. So there is a lot of resources available. PV Watts and NREL has some databases on this, but really we need to use a map, and then you can figure out how many sun hours you get per day. That's the map. I found this map actually in the back of an old AEE solar catalog. That was back when they still made catalogs, and you would go through the first few pages, and it'd be products, and in the back there'd be voltage drop tables and irradiance tables. So keep in mind, when we're off grid, we're not using the average. We're going to use worst month of the year solar irradiance data. Please put in the Q&A if somebody still has one of these. I know that with Aurora, there's all these different modeling techniques, but I found the Solar Pathfinder a great tool. And I still kind of use these sometimes when I go out to a homeowner's house, and I would never go up on the roof with the homeowner. I usually put it on the deck in the back, but we could take a look and help them understand, how the sun travels across the sky. It travels across these little arcs, and I could say, hey, look, if you cut down this tree here, we could open up a little bit more of the solar window for you. And frankly, it might not matter much if it's over here on the far left, because the sun's really low in the sky. Again, there's a lot of other tools out there, but let's take a look. Mike, is anybody still using this, or any questions or comments that have come in?
Yeah, absolutely. Joy commented saying that she has one. Sam and Haas.
Great, great, I love it. And they actually have another app with this. I still like getting out the chalk pen and drawing it out, but they've advanced a little bit. I hope to see it. So remember, we looked at that map. We looked at the map and we figured out how many sun hours we get. And I chose the location where we get about 4.6 4.6 kilowatt hours is our consumption. That was our consumption. Remember, we figured out our loads. We also wanted to account a little bit for battery inefficiencies. These batteries are really efficient. But then I'm going to add in a lot of other inefficiencies. In fact, I'm going to take only 60% of that. And so what I'm doing is I'm taking I need to produce 4.6 kilowatt hours per day, right? So if I have if I have 2 sun hours and I had a 2.5 kilowatt hour array, that would be 5 kilowatt hours. But in this math here, I'm showing you 2.5 kilowatts of solar is not going to be enough. In fact, the math shows out I need a 4 kilowatt hour, a 4 kilowatt array, because of inefficiencies with the tilt, the shade, just the system inefficiencies, and the battery inefficiencies. So if I go put a 4,000 watt system, a 4,000 watt array out in the sun for 2 hours, I'm not going to get 8 kilowatt hours. I'm going to get more around 4.6 kilowatt hours produced. So again, that has to do with the temperature, the latitude, that air mass we talked about, and the angle of the panel. So you really have to understand that we need to oversize some of these systems. And that's what I'm going to come up with, right? So we use 4.6 kilowatt hours a day. We have 4 kilowatt solar system I'm going to put it on. So if we have 4,000 watts of solar, now we need to choose a charge controller that's capable of handling 4,000 watts. I could do Outback. There's still great products out there. You can see the inverter, the charge controller, the Mate 3S, the automatic generator start, all kind of separated out. That Midnight Solar, I think, is somebody who created these. But I can come down here and I can see that for a 48 volt system, I can use 4,000 watts can be handled by this FlexMax 80. Additionally, I could also use the charge controllers, which are built into a solar. They can handle 13,000 watts, and they have several MPPT inputs. So I know I'm good there. And then we need to talk a little bit about our inverter, right? It used to be back in the day, we'd have all these parts and pieces. Now we have these hybrid inverters. If you still have one of these parts and pieces or hybrid inverter, our batteries can work with both of these systems. In fact, we have integration guides that tell you how to program all that Outback equipment or that Schneider equipment or that MagnaSign equipment in an appropriate way to treat our batteries correctly, like the float, the bulk, the max charge rates as well. So again, we can look for some of these high quality inverters. I'm going to go ahead and choose that solar, right? Remember back when in the beginning we talked about 1700 watts is continuous, but we need an inverter capable of handling 2300 watts of surge. Well, it turns out that this solar 12K can actually do 9,000 watts in an off-grid situation. So we're good there. Also keep in mind that that's VA, volt amperes, which I don't want to get too deep into. We're kind of coming up on time, but there is some that comes into play when we're doing some motors. One thing I also realize in off-grid systems is in AC, we're not really thinking about, we usually don't really think about in AC, we think about ampacity more than we think about voltage drop. But sometimes we can reach that limitation with voltage drop before we get to the ampacity. What I'm saying here is here's a sunfrost here, and that sunfrost is going to use 10 amps at startup, 24 volts, and it's 35 feet away. So if I were to say, oh, we just need 10 amps, that's no problem. And if if I go and look at the code table in the NEC, 10 amps, I could use 14 gauge wire. But if it's 35 feet away at 24 volts, I need to actually up that to 8 gauge wire. So keep in mind that a lot of times, especially if you're having DC loads, you're going to need to upsize that wire, even though you're good on ampacity, for a voltage drop, which is usually a 3% is acceptable. Sometimes I've seen 5% is sometimes acceptable. We're going to need to upsize that wire as well. So here's our system. This is my off-grid cabin up here in the Redwoods. I know I use 4.6 kilowatt hours a day. I have a 19 kilowatt hour battery. I got one of my nice 6.6 stacks, 4,000 watts of solar. I got my inverter that's totally capable of handling both the surge and that photovoltaic input. And I'm going to go ahead and pair it up with my 13K generator. Mike, I'm going to keep going. We're kind of coming up on time, but we'll carve out some time at the end for questions here. This is my dream off-grid system, right? So I bumped it up from the 12K to the 15K. I've added a bunch of more solar panels. I've got 19,000 watts of solar. I got some optimizers. I've bumped it up to 2 stacks of battery. I bumped it up to our 22K generator. This is gonna be my dream cabin here as well. These are new systems we've been talking about. There's absolutely still a market out there for you to go out to existing homes that had lead acid batteries and replace them with lithium ions. This is an example where we took out all of these lead acid batteries and we replaced them with just these 5 batteries. And the batteries on the right have just as much usable capacity and have the ability to discharge themselves at like a C/2 discharge to power that radiant inverter you see there. So this is kind of my example, right? This is the example I just showed you, right? In that bank, there were a bunch of 6-volt batteries wired in parallel in series. We had 16 of them. And each of those batteries had about 1.3 kilowatt hour capacity. But what we were doing is we were realizing if you strung all those together in series and parallel, we get about 21 kilowatt hours, but only about half of that is usable because we can't discharge those batteries all the way. So we get about 10,000 kilowatt hours, 10,000 watt hours, sorry. What if we could do is we come back in with a new battery bank of these 5 batteries. We can now use these. Now they're technically 3.8, but that's at 51.2 volts. And I'm keeping apples to apples here, so I decided to go with 48 volts. We got the same usable capacity out of 4 of these batteries compared to 16 of these batteries. So it's an amazing opportunity to come back. There's no watering. There's less maintenance as well. So you don't have to remember any of that sizing exercise. Why? Because Northern Arizona's Wind and Sun has a great off-grid calculator. NREL has a great one here as well. And remember, we have those integration guides that show you how to program all of that equipment as well. So you do usually get a homeowner that says, my lead acid batteries are dead. You offer them lithium, and they're like, that is way more money than my lead acid batteries cost as a replacement. So you have to kind of show them the value, right? What is it going to look like for 2 sets of lead acid batteries? Because you know these lithium ion batteries are going to last at least twice as long as a lead acid. They take up less space. They take up, they don't have any ventilation. So there's those ancillary costs. But what you do is you can do the math. You can take the price of the battery divided by the capacity, the warranted number of cycles, the efficiency by the depth of discharge. And if you do that math, you come up with the price per kilowatt hour, right? How much is it for every kilowatt hour I put in? How much is it for every kilowatt hour I take out? And this is kind of a comparison here. I'm not going to walk through this whole chart, but you can see the 5 batteries come in lower. If I were to update this and put in our new 6.6 batteries, they would be even lower. 6.6, we're being really aggressive on the pricing. So if you haven't looked into that, please check that out and let us know. Cold weather definitely affects batteries during the charge cycle. We have optimized the electrolyte in our new 6.6 battery to go down to 14 degrees Fahrenheit, which is relatively cold compared for California. Maybe not you up there in Wisconsin, Mike. But we do, if it does get colder than that, we have heating options as well. Keep in mind, this is cell temperature, not ambient temperatures. And we do have a whole talk where we go through a lot of this stuff as well. These are some of those cabinets that we have up here, and they're paired up with a lot of our Solarx. Really excited to be working with Solarc. They're an American company down in Texas. We're an American company up here in Wisconsin. So we have American-based IT. Software is becoming so important in this industry. American-based manufacturing and American-based tech support as well. So really excited to be partnering with them. Absolutely, we have ability to pair our generators up with them. And we're a company with a long known history with a global footprint as well. Talked a little bit about cycles. Even at 100% depth of discharge, you're getting like 6,000 cycles. And if you divide that by 365, that's like 16 years. And the difference between the 4,500 and the 6,000 isn't necessarily the depth of discharge. It's actually the rate at which we're charging and discharging the batteries. So you can see it's like a C/2 discharge rate, which is 0.05, or maybe C/1.2 or so with that 0.75. So a lot of cycle life in these batteries. We're still using lithium iron phosphate. Mike, did we have any questions or comments before we get wrapping up?
Yeah, I think we addressed most of them publicly or privately for the comments. You know, a lot of great suggestions for some reading materials. Certainly that home solar or home power digital archive was a great suggestion.
Yeah.
Daniel, we didn't get to chat beforehand. You'll want to make sure you give me the right number so I can pick that random name.
Yeah.
But we've got just a few more minutes. Thank you.
Yeah. Mike, you should be able to figure it out. Anyway, off-grid qualifies for the 30% tax credit. Understand, even if you are on grid tied, there's a great website, Desire, DSIRE. They have a database of all the local, state, national, and local incentives, and not just for solar, but for energy storage, heat pumps, heat pump water heaters as well. And they're also going to let you know what your local interconnection policies is as well. So make sure you check out Desire. It's a great resource as well, and you can figure that out. Be careful talking about the 30% tax credit. Make sure they have a tax liability. Make sure they understand that, so they're not caught up on that. And that's kind of what I've seen in the industry is these door-to-door solar high pressure salespeople in the solar industry are giving the rest of us a bad name. careful with that. Be honest. Be a great installer. If you're here on this talk, I know you guys are as well. Here's a great the stacking nature of this as well. The battery 6.6. We're coming up on time, so I'm going to speed it up a little. But there is still a status indicator on this system. So you can. It's not like the old Trimetrics battery meter in the Power Shack where you go out and tap it and see what you're at. Of course, you're going to have apps that help you look at the status of your batteries, but there still is an indicator. A lot of people have stacking batteries now, but we actually have one that can stack without having to run power conductors or communication lines, right? Our rapid stack connector connects it all together, and they all stack nice up with these integration alignment pins. There's those PHI on the far left. That's a great battery for off-grid lead-acid battery replacements. Our SimpliPHI, our SimpliPHI batteries do have comms, and then our outdoor rated batteries as well. High voltage is definitely becoming more popular, especially when we're starting to look at that Solar 30K 208 3-phase or the Solar 60K 480 3-phase. We have high voltage batteries that can pair up with those inverters that are needing not a 48-volt nominal battery. So take a look at those. Excited. We're going to have some of these down at RE+. Remember, if anybody needs a free pass, put it into the Q&A. Be sure you get a free pass down to RE+ as well. Generators is something we've always been doing here at Briggs Stratton, and a lot of these generators on the market are what are known as standby generators. Well, a standby generator is there for emergencies. We actually have received a EPA certification to use our generators in off-grid and demand response applications. So the ones you see on the left there are our air-cooled generators, and we do have commercial ones that can operate on 3-phase systems as well. Also, transfer switches play a part. But these are the ones, our 18, 22, and 26K generators do have that EPA cert for off-grid use. The warranty changes a little bit, but it's still opportunity for us. Thank you, everyone, for being here. We're about to put up the email for the NABCEP certifications. But remember, having these energy storage systems combined with an off-grid system, even on a grid, is with these new net metering rules, is still playing a big role in this industry, and you can still get that. Before we get up to our email, I would love anybody on this talk to please join our IQ program. And I'm sorry I didn't put up, but we have some promotions coming up. $1,000 off your first install, and additionally $100 per battery. That is a rebate that goes on indefinitely as part of being in the IQ program. Scan that QR code to sign up, and we'll happy to work with you.
And Daniel, just a couple of items in the Q&A. One question about does the tax credit qualify for off-grid homeowners? I think we, as always, want to recommend reaching out to a tax professional. Kind of don't see why it wouldn't, but check with an expert on if that would qualify. If you pull up the Q&A, Lauren has some comments around net metering. Sam, also looking for a free pass. So any of those passes that you're looking for that Daniel might have, again, reach out in the Q&A and we'll look at that afterwards. Joy had a question about the monitoring system. So Energy Track, our Briggs Stratton monitoring, great for system updates down the road. And the MySolark monitoring, a great app for tracking, solar production, energy usage. But is the off-grid system monitoring for Solark, Briggs Stratton? It's all applicable. Certainly, there are some limitations with the Energy Track software updates requiring an internet connection that we can address offline. And Eric asking about our generators. Our generators are natural gas or liquid propane driven as well.
Yeah, thank you. Really quickly, I'm going to address some of those questions more in depth. If you need NABCEP credits, energy storage training at basco.com. Energy storage training at Briggs & Stratton Company is Basco. Email me. I will be happy to get your NABCEP credits. Sam, please email energy storage training at basco.com. I'll try and reach out to you too. I'll look for you as well and get out to you. Lauren, you made some great points. Essentially, the utility industries are kind of providing a false narrative on why they changed out of net metering. They're not giving credit for us providing powers to our neighbors. Lauren also brought up that time of use rates, right? We can discharge our batteries during time of use. So very interested in that. Please keep in mind also, Eric, about propane generators, that we have NG Max. A lot of people run generators on propane. You would if you're off grid, but if you're running it on grid, on a grid tied system, it's most likely going to be natural gas. The winner is Eric ZC. I'm sorry if I butchered your last name. Eric is the winner of our Lego contest. I will say this: if anybody comes to RE Plus on this talk, Sam, I guess that means you, I will make sure you get a Lego kit as well. Welcome. Thank you, everyone. And we'll see you guys next time. Please email me if you need your NABCEP credits. Thank you.